So hello everyone. In this problem, what we have given. So the name of the problem is path sum 2. Path sum 2. In this problem, we are given a root of a binary tree and a value. So suppose this is the binary tree. 5. From 5 we have one node 4, one on the right which is 8, 1 11, one on the left 7, 2, yes 13, yes 4 and 5 and 1. So suppose this is the binary tree and we are given the root of the binary tree, and we will also be given a target sum. Let's say in this case this is 22, and we need to return the sum of all the nodes value that are fulfilling the criteria. What is the criteria? The criteria is that we need to return the root to leaf path where the sum of the node values in the path equals to the target sum. So what does that mean? That means that from root to a leaf is the last node where after that there is no node. So the left node is also null and the right node is also null. So at that point when there is no node or the left and the right node of a node is null, then we call this a leaf node. So from root to leaf, if there is a path, suppose this is the path, so what is the sum of all the node element? This is 5 plus 4 plus 11 plus 7. So 15, 20, 27. So the sum of all the nodes from root to the leaf for this case is how much? 27. So we need to find that if there is a path where the target sum, where the sum of the nodes from root to left is equal to target sum, and if yes, then we'll add that to another vector. Let me just give you an example. So suppose we are given the target sum as 27. So this is our node. Suppose we are given target sum is 27. So that in that case this will satisfy. So what will be the answer in this case? We will add that to our answer. So suppose answer is a vector which will contain integer inside this. So we'll say that okay, add this vector which will contain all the nodes of that path, put it inside another vector. Let's say it's v, and push v to our answer. So answer will now contain v, and like v there will be v1 v2 in more than one or two more than one vector there. The answer will consist of more vector which will be another path which will satisfy these conditions. So as we can observe that the element in the vector will be in integer form, not in the tree node or any type of pointer. So for that we need the value of that node. So what can be the way to select that? Okay, this is a path that is satisfying this condition. This is the path that is not satisfying the condition. So what can be the way? So as in the question, target sum is given as 22. Let us consider that. So how many paths are there that has target sum 22? Let's see. As we have discussed, this path is not having a target sum of 22. It is having target sum of 27. Is there any more path? Yes, there is. So what are this? So this is root. And what are the leaf nodes? This is the root node. And leaf node, this is a leaf node. This is a leaf node. This is a leaf node. And also this one is a leaf node. How am I saying these are the leaf nodes? Because they have no more nodes after them. So if there are any nodes, they will be null. There are nodes after that, but as they are containing null values, we are not considering them. So let us just check for these three and these four leaf node, what are the path sum of them. So 5, 4, 11, 2. This is 1. So let's say this is one path, 5, 4, 11, 2. What is sum of them? Sum of them is nothing but 11, 4, 15, 22. So 22 is the sum. This is the sum. So as this is matching our target sum, which is 22, and the sum of the path from root to leaf node is also 22. So we can see that okay, this is our answer. So we'll put that into our answer. So answer will now consist of this one path. So 5, 4, 11, 2. Remember, this is in integer form, not in a root form or any pointer or tree node. So let's check for this one. What is the path sum for this one? This one. We need to check for this one. So 5, 8 and 13. So 13, 8, 21 and 26. So the sum is 26, which is not equal to our target sum. So we will not add this to our answer. So let's check for now this node 5, 8, 4, 5. Let's check for this one. This one. So 5, 8, 4, 5. So 5, 8, 4, 5. Is this a valid path? 5, 8, 4, 5. Let us check. So 10, 18, 18 4s 22. So the sum is 22 and our target sum is also 22. So yes, we can say that okay, this is a valid path. So if we find any valid path, what can we do? We add that to our answer. So answer will consist that in those integers that are forming the valid path as a vector, and we'll put that vector in vector which will consist of integer values. So 5, 8, 4, 5 is a valid path. Okay, good. So now there is one more path which is left, and the path is this one. 5, 8, 4, 1. So 5, 8, 4, 1 is left. Let us check for that also. So 5, 8, 4, 1. What is the sum? 5, 4, 1, 5, 10, 10 plus 8, 18. 18 is the sum. So we'll check that okay, is 18 the sum of the target sum? No, target sum is 22. We are getting 18, so no, we will not add that to our answer. So okay, we have two vector in our answer vector, and this is the answer. Yes, so this was the thing that we need to do. But how can we do this? How can we store that okay, after 5 there is a 4 and there will be 11 and there will be 2? How can we check that? So if we try to think about the traversal approach, we have 3 traversal: in order, pre-order, post-order, and one level-wise traversal. In any traversal case, what we do, from root node we go to left and right node. While doing that, can we say that okay, until we are getting our leaf nodes, because we need to check from root to leaf node, the path from root to leaf node. So can we say that okay, from root to leaf node, if we check that okay, this is a leaf node, suppose here we have come, okay, this is a leaf node, and the path from 5 to 7, this is containing the integers that are sum up to the target sum, that are going to sum up to the target sum. Can we say that? Yes, definitely we can say. So for doing that, the first approach that should come to our mind is traversing from here to here and storing the value of that node, and check if the sum of those values are going to equal to the target sum, and if they are equal, then we'll add that to our answer. So if we try to check for every path, we need to traverse from that route to the leaf every time, but we don't want to do that. Can we observe one thing here, that up to 11 we have 5, 4 and 11. If we use a data structure, let's say it's a vector, which will store all the path, all the node value from root to that path, that root for us, and after going left or right, we also add that to a vector. So until this point, our vector will consist of 5, 4 and 11. And if we do one thing here, while going to left, we push 7 to left, 7 to the vector, and after going to right, we remove 7 and we add 2 to that. So when it will go to 7, 7 is the leaf node and both the node after that is null, so we can easily check that okay, this is the leaf node. So can we do one thing here, that okay, this is the leaf node and the sum is not equal to the target sum, so we are not going to add it, so we will simply return from that. And if the sum is equal to 22, okay, this is our answer, so we will put that vector to our answer vector. So we will initially get our answer vector. We can declare that globally also, which will contain integer. Let's say it's our answer vector, and another vector which will store all the root values from root to, so another vector which will store all the values from root to leaf node. And what can we do more? For doing that, if we have, let's say, 5 for 11, we need to check, okay, so let's do the sum and let's check for the past sum. So if we have 5 for 11 and 7, so we need to add the the sum in the vector, all the elements in the vector, and sum them up to check whether this is a valid answer or not. What can we do? We can also initialize another variable, which is, let's say, current sum or something like that, which will store the current sum of that element. So till here that will be 5, after this will be 9, until there it will be 20, then here it will be 22. So we can easily check that. So this was the explanation part. Hope you like it. The part 2 will be of the coding part. I would recommend you to solve this problem by yourself once, and if you are getting stuck at any place, you can check the coding part also. Thank you.